Welcome to episode 326 of CppCast, the first podcast for C++ developers by C++ developers. I'm host Rob Irving, joined by my co-host Jason Turner. Jason, how you doing today?
I'm all right, Rob. How are you doing?
I'm doing okay. It's been a while. We were doing the math before we started, and we've actually not recorded together for like 3 weeks.
Yeah. Well, I mean,
Feels
it's like the
forever.
longest stretch in several years at this point.
Yeah. So I'm sure everyone who's a regular listener saw we did miss a week last week. So apologize for that, but we were both kind of getting back from vacation and getting in the swing of things, and it just didn't work out.
Yeah. And hopefully Connor made an acceptably good co-host.
Yeah, Connor was great to have when we had Gashper on talking about deducing this a few weeks ago. Yeah, he was good.
Cool.
All right, so at the top of every episode, I'd like to read a piece of feedback. Since we did miss last week's episode, I put out a tweet about that, and we got a couple nice responses. This one was from Guy Davidson saying, "Best wishes. Everyone needs a rest sometimes. By the way, if you want to talk about the Rainbow Flower book I wrote with Kate Gregory, it's due out December 23rd. We'd love to be on the show. And yeah, we're looking forward to talking to Kate and Guy within the next few weeks about the new beautiful C++ book." Yeah.
I appreciate that it has a beautiful cover.
It does have a very beautiful cover. Yeah. I'm looking forward to hearing exactly what the book covers.
Yeah, me too.
All right. We'd love to hear your thoughts about the show. You can always reach out to us on Facebook, Twitter, or email us at feedback@cppcast.com. And don't forget to leave us a review on iTunes or subscribe on YouTube. Joining us today is Dr. Daisy Hollman. Dr. Hollman has been involved in the C++ Standards Committee since 2016, where she has made contributions to a wide range of library and language features, including proposals related to executors, atomics, generic programming, futures, and multidimensional arrays. Since receiving her PhD in quantum chemistry in 2013, her research has focused primarily on parallel and concurrent programming models, though a broader focus on general accessibility of complex abstractions has become her focus in more recent years. She currently works on C++ language and library design at Google, where she continues to focus on providing broad accessibility of programming models and library interfaces, with a particular focus on design for diversity and inclusivity. Daisy, welcome to the show.
Hi, thanks so much for having me.
Oh, can you tell me what the heck quantum chemistry is?
Quantum chemistry is just quantum mechanics applied to chemistry. So because you happen to be studying the Schrödinger equation of electrons, they call it chemistry because chemistry is really about electrons. But like most of my classes I took from either the physics department or specifically from quantum chemists. So it was like, it's kind of a mix. I tell people quantum mechanics sometimes. It's just
okay.
What my PhD is in because it's a little bit easier for people.
What was the, did you do a thesis PhD based?
My dissertation was a bunch of my papers smashed together. And I needed to come up with an underlying theme. So I think I called it like correlated electrons in chemical systems, which is like another fancy way of saying chemistry.
Oh, okay.
But yeah, it's really interesting. I think a lot of people end up in programming models out of quantum chemistry just because there's this demand for scale coming from the biology side, and there's this demand for precision coming from the physics side. And so the intersection of those means you're doing really complicated problems on really large computers, which means you have to design very, very careful abstraction layers. And that's how I ended up in C++ and in C++ programming models design.
Wow.
Very cool. All right. Well, Daisy, we got a couple news articles to discuss. Feel free to comment on any of these, and we'll start talking more about your CppCon talk and some of the ISO papers you worked on and stuff like that. Okay.
Sounds great.
All right. So the first thing we have is a link to JetBrains and their CppCon 2021 videos. I think when I had Gashper and Connor on in the last episode, we were talking about where the CppCon videos are currently located, because you can't just go to YouTube yet until they're all published, I guess. But JetBrains has this link where you can go and peruse all of the videos that have been published so far. So I wanted to make sure we put that in the show notes.
Yeah, it looks like it's specifically the plenaries.
I was just looking, and it looks like it is more than that. On the bottom, underneath the plenaries, is a link that's just CppCon 2021 talks, and that opens a YouTube playlist, which includes all the plenaries, and then I see Eric Niebler's 2 talks on working with asynchrony generally, and it says there's 45 talks or 45 videos total. So maybe that's all like the day 1 videos. I'm not sure, but
I didn't see it was
like
a playlist. I saw it was
progress.
Eric's. I knew Eric's went up.
Yeah.
I knew the plenaries were up.
Yeah, so for all those listeners looking for watching more of the CppCon videos, definitely look for this playlist on the bottom because, yeah, 45 videos up so far. All right, and then the next thing we have is a Reddit post, and this is C++23 near the finish line, and it's kind of going over the progress as we approach the so-called feature freeze of C++23. And Daisy, you're telling us that you've been kind of involved in a lot of these, right?
Yeah, I mean, I've kind of taken a little bit of a break from C++ committee involvement when I moved to Google from the national labs, but a lot of these papers are things that I was involved in at one point or another, and the post, I think, reminded me of why I really enjoyed contributing to these things. And then the comment section reminded me why I've been taking a break. Yeah. So STD execution, I think it's an excellent paper. I don't want to start a flame war in the comments of your
that doesn't tend to happen for the podcast, just so you know.
Doesn't
that's good.
Doesn't tend to. It has once or twice.
It depends on who the guest is. I think Bryce got some comments aimed at him when we had him on talking about ISO stuff.
Yeah. So I mean, it's the SID execution is I think a big underlying topic of this post. Like, why is this getting so much time when it's quote unquote so new? Which
and this is the kind of the replacement for executors, right?
Right. It's the cleaning up of the compromise executors proposal, which was P1194, which was a compromise between P443 and 16 something. That was the Eric, Kirk, and Lewis's paper back in 2018. 443 was already a compromise executor proposal between three proposals before that, one from NVIDIA, one from Chris, help me out, what's his last name? He's Australian. I'm blanking on his name, and I should know this, but
Christabella, I believe is what you're looking for.
No, not Christabella. The other Australian Chris.
Oh, I'm sorry.
No, he works in finance, does Bustasio. Anyway,
I'm not sure.
He's going to be really upset that I forgot his name. But and then Google was actually involved early in this. I think the first paper on executors was 2012, right?
Oh wow!
So I mean, I think a lot of this post is talking about like how why is executors getting so much time when you know the paper that the discussion's about is only 5 months old, which is. And actually, the original poster mentions me in one of the comments, says like, I went back and watched Daisy Hollman's History of Executors talk from 2019, and I don't think that the 2300 closely enough relates to, you know, the history of executors, which judge for yourself on that. I don't know, but anyway, that, and then there's a lot about P0009 in here, which is the multidimensional array. And then basically anyone coming from scientific computing, the only thing they can comment about is, well, why don't we already have linear algebra? This is ridiculous. It's been standardized since 1979. Why isn't it part of the C++ standard? And I agree. I'm not in scientific computing anymore, but I think everyone in scientific computing is just shocked that there's no standard linear algebra and hasn't been yet, even though like the BLAST standard is effectively as old as C++ itself. That's the typical reactions we get to those papers every time they come out. It's like people who haven't been involved in the executor process are like, why are we talking about it so much? This seems super new. And it's because every time that we talk about it, there's enough objections that we have to write a new paper that makes a compromise.
Right.
And so it always looks new. And then the talking points on linear algebra and multidimensional arrays are always just like one community being like, how in the world is this not already in the standard? And another community being like, why are we wasting time putting this in the standard? Yeah.
Well, if you look at the Mdspan, what does that say? 74 months that the paper's been in process?
So I'm one of the probably 5 people who at one point in time called P0009 my baby. I kind of carried the lead of the torch for that for about 2 years. And yeah, I mean, part of that was that there were a lot of people coming into that originally from scientific computing who had very little programming languages experience trying to standardize something. And we were trying to standardize something very, very complicated. So I actually wrote the production implementation of Mdspan that's being used at the national labs now.
Oh, nice.
And hopefully, if we can work out all the politics, is going to be contributed to all 3 standard library implementations. MSVC might be a stretch, but the other 2, it should be able to be contributed to. And it is, I mean, I think personally, it's a contender for the most complicated piece of code that's going to go into the standard library. Right next to std-tuple. Like maybe some of the constructors of std-tuple are a little bit more complicated. But there's sub Mdspan is just an incredibly messy bit of metaprogramming that has to work very generically between static and dynamic extents and has to maintain them through slicing and all kinds of other things. And it's an incredibly complicated paper. And, often library proposals get written as like you write some library feature in code, and then you like try and back out the actual like standardese for it. And this is like kind of sort of that. Except for the standardese is just immensely complex for this paper. So that's another reason why it's so old. So it was like had people who didn't know how to write standardese when they started it, working on it, and then like this paper actually was originally an n-numbered paper, so it actually predates p-numbered papers.
Oh wow!
But and then like yeah, it's been through some changes since then. It's been on the cusp. It was on the cusp of making C++ 17. It was on the cusp of making C++ 20. It is now really on the cusp because I think we have several people who really know what they're doing involved in it. And I think it's actually going to make C++ 23, especially now that we have a reference production implementation that is in use at the national labs, in production code, being run on giant supercomputers. There's really a pretty compelling case for it to make the standard. So I'm excited about that.
It's in the top category of papers that are expected to make it, right?
Yeah.
It's not in the no category at the bottom.
Right. And hopefully it's, it's kind of in that category, like multidimensional arrays in general are in that category of things that are really hard to get through the standard because it's simple enough that everyone has an opinion on it, right? So like one of the most contentious things that we had in the standard, in the last standard, was like size types, right? Like size types for containers. That discussion was epic and super long, and it's because it's so small and simple that everyone has an opinion. And in fairness, it's not that everyone, like a lot of people have a relatively informed opinion on it. It's just that it's simple enough that people can form opinions on it pretty easily. Whereas a lot of more complicated things like, I don't know, the barriers work, for instance, that came out of SG1, STD barrier, that has some really complicated things involving memory orders. And so a lot of people just are like, yeah, sure, the experts looked at it. Sounds good to me, right?
Right.
Whereas I don't know who's an expert on size types, right? And multidimensional arrays are kind of like that, right? Everyone uses arrays, so everyone kind of has an idea of what they think that like multidimensional arrays should look like. And so you get a lot of feedback, you get a lot of opinions, and you have to handle those opinions. And that's not a bad thing, but it's not a good thing for velocity, at least, right?
Right. I have a random aside here, tangent, I guess, a little bit, but Mdspan, can it handle an arbitrary number of dimensions? Is that how it's written?
It can.
Okay.
I tested my reference implementation. So I did a paper on this for supercomputing in 2019. It was a supercomputing workshop. I can get you a link to it for the show notes.
Okay.
But high performance computing people are very skeptical of abstraction, right? They're like, if it's adding, 5 instructions or something like that, then I'm out. I'd rather have the code be less readable or something like that. Like we can talk about whether or not that's a really good or healthy position for them to be having, but a lot of them do, right? A lot of them are skeptical of C++ in general. But so in this paper, we basically showed with several micro benchmarks that the Mdspan was producing the same code and was micro benchmarking at exactly the same speed as like the same thing done with just pointer arithmetic.
Oh, wow.
With like raw pointers. And one of the things we did for that paper was just push the limits of what the compiler could handle with the in terms of inlining and in terms of constant propagation. I got GCC to constant propagate dereferencing a sum over a 74-dimensional array. Now, most of the dimensions were size 1, but and it was able to constant propagate the entire array, dereference, constant propagate the entire sum, and compile the function into like return 42 or something like that, if the sum was actually 42 and if it was given constants. So it is actually very powerful, and the ability of compilers to cut through abstraction is just way beyond what most people estimate it is. Way, way beyond. People are skeptical that like a compiler can cut through an 8-dimensional array, and I'm just like, here's 74.
Right.
And it is all const_expr correct. So the entire, all the things that are supposed to be marked const_expr are marked const_expr, and the compiler can do these things inside of static asserts, albeit very, very, very slowly. But yeah. So that was actually a really fun. It's the hardest piece of code I've ever written in my life. I don't know that I'll ever write anything that hard again. Maybe, hopefully not. Maybe, hopefully so. I mean, I enjoyed it a lot. It was a lot of fun, but this is definitely a challenge.
That's a fascinating point, because you also pointed out that it's simple, quote unquote, simple enough that everyone feels like they can have an opinion, but clearly they don't understand the implementation complexity involved.
Right. Right. Especially if you're doing this thing as a library feature and not with any language support, right? So, and I think it is correctly done as a library feature. Don't get me wrong. I think that a lot of the customization point design and the use of generic programming in P0009 is in line with the standard template library as it was originally envisioned, right? In line with the ideas behind STD vector, in terms of the ability to customize for different domains and provide reasonable defaults.
All right. So last thing we want to talk about was this CMake 3.22 release announcement. Anything big going on in this release, Jason?
Yeah, I was just going to say, you usually rely on me to point out what was big in the CMake release. I mean, it looked like my main takeaway from this one, because there's so many like little details, like whether or not you can set a variable to say that a find package to a future package name must be a required, like to override some of the features of find package or whatever. A lot of these things just make me go, you know, like once a year, you just need to go over your CMake code and be like, is there a better way to do this with modern CMake today? It's just like your C++ code. You need to do a modernization pass every now and then with your CMake. Also, I think interesting to note that Visual Studio 2010 is officially being dropped from CMake. I don't think I've ever noticed CMake deprecate a feature like that before.
Well, it must be every few years getting rid of old Visual Studio versions, though. I'm assuming they don't, support anything prior to 2010, right?
I don't know. I guess not. But I mean, I just hadn't noticed it before. That's all.
Yeah.
Daisy, do you have any opinion here on this CMake release? Do you use CMake?
I use CMake pretty religiously at the National Labs. I was a strong advocate for CMake, just as like, it's the best that we've got. Let's just use it and coalesce around it. And it took me about a week and a half of being at Google to realize I was completely wrong. And Bazel is onto something that is much cleaner and more scalable. So that's all I'll say. I'm drinking the Kool-Aid now, and I think Bazel is fantastic, and everyone should who's considering switching build systems, especially now that Bazel has CMake compatibility and can interact with other CMake libraries. So you can just import CMake directly. You can import AutoTools stuff directly. I would consider, if you're already on CMake, it's not worth the effort, I don't think, to switch.
Okay.
Unless you're really considering like completely overhauling your CMake. But I let build some systems experts do build system-y stuff and stick to what I'm good at.
Did we do a Bazel episode? We did.
I think we have. I was going to say maybe we should do an update on some of those topics at some point.
Yeah. All right. Well, Daisy, I think to start off, we already talked a lot about Mdspan, which is one of the things we want to talk about. But the other thing we want to talk about was your CppCon talk, the 2 cute C++ tricks. What was the inspiration for that talk?
So the interesting thing is, I think this actually started while I was writing. I think like my very first one started while I was writing or maintaining the P0009 production implementation, because there's some kind of scary things you have to do with parameter packs just to make Mdspan work. And I was just like, wow, this is like something I never should be writing in real code. I have to write it here because it's standard library code. But I bet people would be interested to know that this works this way. I think really why it got a lot of uptake is because I just happened to, at that time, be experimenting with a new screenshot generator that could like generate screenshots of code snippets. I think it's called Petrify on Mac. I'm very happy with it. You should, we can put a link in the show notes, I guess.
Yeah.
Not endorsed or anything like that. I don't even know I think it's a free tool anyway. But there, I think because people could just read the code right there, and it was short enough to like feel like a tweet-sized thing, people really seemed to like it and were interested in it. And so I started doing it kind of regularly. It was kind of addicting a little bit, how social media can be. But it was also fun to see what people were learning, see what people had to add to this. Richard Smith started chiming in every now and then. Some of my favorite tricks were the ones that, Richard responded something to, and then I kind of riffed off of that into a new trick or something like that. But yeah, it's I don't do them daily or regularly. Sometimes like I went 6 months without doing one just recently. I call it the cute C++ trick of the day, but it's like day just happened to be the time period I chose at the time. And I have done them like one every day for a week before, but now I feel like my own like bar for quality for putting one of them out has gotten to be so high that I kind of agonize over them for weeks. I have like 4 or 5 in the works right now, but like they're not quite pithy enough and they don't quite demonstrate the concept clear enough. And so I'm kind of trying to work them down into like these nice little catchy things. But it's fun. It's a fun little side project. I think people are learning a lot from them, and I think that's really cool. The cool part for me.
That's funny. It makes me think of, sometimes people will comment like, making a well done lightning talk can take as much effort as like a keynote. And that's what you're talking about, basically tiny little lightning talk snippets that you're trying to refine to the perfect thing.
Exactly. And it has to fit into the image that kind of, pops up on people's phone without them having to click on it, because otherwise people won't click on it. And I've kind of looked at the numbers of how like long that is, and it's about 20-ish lines. So like trying to say something profound that's surprising to people in C++ in 20 lines is hard. I think Shafiq does a really good job of it in his like C++ polls or whatever. It's the same kind of thing. So yeah, I think it's a fun little challenge. I think Matt Kulakundis had the greatest name for it. You've heard of code golf, right? Where you're trying to actually get the number of characters down. And this isn't really about getting the number of characters down. It's about really getting the most creativity into the fewest kind of lines or whatever. And so he called it code mini golf, right? It's like you're trying to hit it off the windmill, through the loop-de-loop, and into the hole or something like that, which I think is a really cute idea. And I think it's a really fun way to learn. Like, I think code golf is a really fun way to learn code too. It's gotten to be pretty intense if you've ever, done code golf seriously. But I think code mini golf is another cute way to learn new things about a language.
So how many of these did you actually present in your talk?
5.
5.
I meant to, well, 5 plus like one bonus one that was part of the same category as another one. But my outline had 12 or 10, I think. And I got the feedback that like, this looks like a 3-hour talk. And I was like, nah, this isn't a 3-hour talk. And then I put it together and I was like, how the heck am I going to fit these 5 into 1 hour? I actually had slides for 6. But there's no way, like I was rushing just to get through those 5 in an hour. But I think my plan is I titled it Part 1 of N.
Right.
Nice.
As like, I think Tony Van Eerd does this with a lot of his talks.
Yeah, a lock-free, multi-threaded queue. This is the longest running one that I know of. Anyhow.
Yeah. And so I probably will do another one next year. I mean, I think it was well enough received. I'm very happy that it was really well received because I really enjoyed making it. I really enjoyed talking about it. So I felt like a lot more nervousness around the talk than I usually do, because I was just like, I really want this to go well because that means I get to do it again, and I'm excited about that. So.
Yeah, it's like the gift that keeps giving there. Yeah.
Yeah. How many of the cute C++ tricks do you have? Like, how many have you put out in tweet form at least?
I haven't counted, but okay. I think I went through and I think there are about, while I was making this talk, I think there are about 30 that I'd like to talk about.
Okay.
Counting ones that I haven't put out yet.
So that's at least 4 or 5
floating
talks
around in my head.
Yeah.
Right. It's at least 4 or 5 talks. Some of them start to overlap with each other. A lot of them are like boiled down to really interesting parameter pack tricks that are pretty redundant, and like, this is good. This is good that we're coalescing around like certain little idioms that people can reuse. And then like expanding on the idiom in a creative way. And so it's going to be interesting to figure out how to organize those into self-contained talks, because like I have to first present the idiom and then present all the ways to expand on the idiom that are, so we'll see.
So obviously listeners should go and watch the talk on YouTube once it's available. But is there any trick that you kind of wish you had been able to get to in your talk that you wanted to share, one that kind of would work in audio format sharing?
Yeah, so I have one that I've been working on for a while that I think I tweeted something about it at one point, but I wasn't very happy with it. So I want to somehow summarize the fact that lambdas and unevaluated contexts in C++20 really, really make the design of metaprogramming libraries super duper easy compared to what they used to. Because you can basically just do decal val of the unevaluated lambda in some wrapper, and then use that as like a meta lambda, right? So I think even dating back to Boost MPL, people have done meta lambdas, right? Just because they're super useful for predicates of metaprogramming algorithms and things like that. But I've been building out a library. I won't say the name publicly of it because I'm hoping to do like a big release of it at some point. But I've been building out a library, not really designed around like the fastest metaprogramming ever, but really designed around like the cutest metaprogramming implementations of algorithms. And one of the base idioms in it is reuse of lambdas for metaprogramming. And I think it makes for surprisingly readable metaprograms. I did tweet out like a version of Conway's Game of Life using template metaprogramming, like compile time Conway's Game of Life in a while back using that library. And it's only like 50 lines, which is of arguably readable metaprogramming, I think.
Arguably readable is better than most
readable.
metaprogramming.
What?
Arguably readable is better than most metaprogramming.
Yeah, arguably readable. I mean, I think doing readable metaprogramming is one of the most interesting challenges for me in C++. I think there's a lot of people that just say, if there's something you would call metaprogramming, you shouldn't be doing it. And I think it's possible that there are code bases where that's true. But even in those code bases, you have to fundamentally answer the question of there are some pieces of code that you have the choice of metaprogramming, copy paste, or external code generation. And all three of those are evil in their own ways. You have to choose the least of the three evils. Hopefully with some reflection and reification stuff coming and generative metaprogramming, this is going to become a lot easier by C++ 26, 29. Yeah, maybe. That's another discussion about the status of that. But the reality is that if you work on a code base now, and this question comes up, you should be asking the question, right? You should be asking, is copy-pasted code more maintainable here than metaprogramming? And if you're not at least asking that question, you're probably making a mistake. If you're categorically ruling out metaprogramming because it's complicated, because it'll slow down your compiler, because blah, 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 like compile time is a cost. Developer time is a cost, right? Yeah. Like weigh your costs, figure something out. So, I mean, I think along those lines, part of the reason why metaprogramming gets such a bad rap is that no one really focuses heavily on readable metaprogramming, right? People focus on functional, like metaprogramming that does the job and you put off somewhere, or people focus on avoiding metaprogramming. But like, there's like, where's the style guide for how to write readable metaprogramming code, readable generative code? I think there needs to be a lot more talk about that. I think I'd love to give a talk on that sometime. That's one of my list of things, like how to write readable meta code when you have to, and only when you have to. But
yeah, that's how I think.
I don't know how we got on that topic. I'm sorry.
No, it's fine though. But so many people think of templates as write-only code, which is kind of, I think, what you're getting at there. And it certainly doesn't have to be. Yeah.
Right. Absolutely. And also, like, I definitely would draw the distinction between generic programming and template metaprogramming. Like,
Right.
some people say because the keyword template is being used, it's template metaprogramming. And I just think I think you are missing out on a lot of C++ if you think that way.
I totally agree with you.
But
so
it is also true that I think a lot of day-to-day developers don't use templates because they're writing code that doesn't need it. And so I think that's also something for us to keep in mind as the, like, you know, ivory tower C++ people who like talk about C++ for fun on a podcast. Like, the reality of a lot of C++ developers day to day is that they don't use templates. And so, like, figuring out how to design C++ for those people as well as for us is interesting.
I think there's a lot of day-to-day C++ programmers who don't use functions either. And, you know, just getting them to use any kind of abstraction would be handy. I'm sorry. I will stop. Anyhow.
No, I totally get it. A lot of C++ programmers do a lot of copy pasting. I wish I had a CI tool that would go through and say, like, are you sure you wanted to copy paste this?
Oh,
50 lines
I can
of
help you
code.
with that. There's the copy paste detector, CPD, copy paste detector.
Oh, really?
Yes, it's a tool written in Java. It's the PMD CPD. I forget what PMD stands for. Their little icon says "Don't shoot the messenger," and it does, because there's well-known algorithms for doing copy paste detection, and it implements one of those algorithms and can give you a full report within, you know, guidelines for how long of a snippet you care about and how many tokens have to be the same or different, because it looks for even the same chunk changed with just a couple of tokens changed in it.
Haven't we also mentioned PVS Studio articles where they do copy paste detection, but see that, oh, you copy pasted this code, but you forgot to change this variable or something like that?
Yeah, but I think that only works within like one function scope.
Okay. Yeah.
I could be wrong. I don't think theirs does a project wide, which I think is what Daisy wants. And
this is beautiful.
You should try running
Everyone
that.
should have this in their CI.
It'll make you sad when you run it. Trust me, it will make you sad.
Yes. Oh, this is beautiful stuff. This is what people need to be using. This is why I'm a proponent of, you know, light, readable, maintainable metaprogramming. Because copy paste code is just impossible to maintain.
Yeah. I've dealt with so much of it. But back to your talk.
Sorry.
No. That's one thing I was curious about is because you titled the talk like 2 cute tricks, and you kind of have this implication that these are things that we shouldn't be doing in real code. And I'm in the back of the room watching your talk, and well, I'm sitting with a certain group of people who will go nameless that are like, yeah, we do that. Yeah, we do that. We do that. And like, so where's the line drawn between these are tricks that you might need depending on what you're doing, and no, really, you shouldn't be doing this?
Well, it really, code always depends on the reader, right?
Okay.
Some code goes from, like, the lifespans of code can be anywhere from, 10 minutes for a script or for, like, essentially a bash command to, like, indefinite, essentially, right? And anything that is long-lived and has an unbounded set of readers should be unsurprising to any reader you can imagine, right? Anyone who would be hired by your company with good enough C++ to be hired by your company should be not surprised by your code, right?
Okay.
I think good software engineering is unsurprising. I think good tweets are surprising. No one's going to retweet something that's not surprising, right?
That's a good point.
Yeah. So I think fundamentally, I'm not disagreeing with the fact that some of these are useful in real code from time to time. I certainly have enumerated a parameter pack before the way that we did it. I think that's the only reasonable way to enumerate a parameter pack in C++. now. I wish we had 4 ... I wish we had square bracket indexing of parameter packs. I'm not entirely sure why we don't. I think that those things could be added relatively easily. But I mean, it's just time mostly is that people haven't had time to add those things. But I think that, yeah, if some of these things would not be surprising to your reader, like for instance, the static lambda one, that's the one that I most got the immediately evaluated lambda in a static initializer has call once semantics. That's the one that I got the most feedback of, like, well, I've done that before. And there's a couple of reasons why people have done that before. It is actually faster than std call once, although...
did you figure that out? I was wondering, yeah.
Yeah. I didn't do any micro benchmarks on it, but if you look at the code generated on Godbolt, it's pretty easy to see why people would at least think that.
Right.
I should run some pretty rigorous micro benchmarks on it. Part of the problem is that, like, how do you run a micro benchmark on something that's run once in right?
Well,
right.
Well, most of the cost is, well, okay, just a guess, but the run once isn't the expense, right? The actual expense is how much does it cost to check to see if it needs to be run the next time. So I think you could do micro benchmark on it and just attempt to call it many times.
Oh, I see. That's interesting.
I could be wrong.
Yeah, that's interesting. I think there's a pthread call once that gets used for std call once, and I think that is actually, like, that jump is actually slower. Okay. Although I would expect not appreciably. I think that most of this code shouldn't be in critical paths, but that is a good point. Like, that's the thing that we should benchmark, right? Is what is the cost after the first invocation? I suspect it's pretty trivial in both caces. But yeah, I don't know. That's the thing we should benchmark. I definitely see why people would think that, though, because it doesn't get inlined. The call to __ CXA guard acquire is inlined, looks like a compiler intrinsic more than like the pthread call once thing. So I don't know. That's a good question. I should have gone and benchmarked it. But my first thought was, like, you know, something that is called once, like, shouldn't be in a critical path. But that you actually make an absolutely good point. It could entirely be in a critical path, just not the calling once part, not the part that gets called once.
I see static objects in the critical path very often, but I
do too.
I don't know if I've ever seen call once in the critical path. So I know I have a feel for the cost of a static object being the critical path, because that can actually be a real expense. But I've, like, never used call once before, so I don't have any context for that.
Yeah, I haven't benchmarked either of them a lot, and if anything that's a static initializer in a critical path, I really want it to be a const expr initializer, probably. Constant evaluated initializer, constant expression. So I, probably would have avoided this kind of pattern, but that's the one I've seen people do a lot. But I think that, like, yeah, all code should depend on the reader, right? None of this is too cute if your code's going to last 10 minutes. Right. But pretty much all of this is, like, if you're writing code that has to last for generations, even if you can't use std call once, you should wrap this immediately evaluated lambda trick in something called, my library : call once, and then use the immediately evaluated lambda there, right? At least isolate the part that's too cute, and then put a profuse comment like, section blah 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 of the C++ standard guarantees that this will be evaluated once. By the first thread that encounters it, all other threads will wait for the initializer to complete. Exits via an exception will cause the next thread that reaches it to evaluate it. Blah blah blah. Like, write out something. Be very verbose. Like, keep in mind that your code is going to last for generations potentially. at many companies, right? Certainly at Google, we have to do that, right? Google
Right.
has enormous amounts of code, enormous numbers of developers, and enormously long-lived code. We're still dealing with fallout from things that we wrote in 2006. And I mean, for the most part, a lot of that has been cleaned up. We have some of the best code janitors in the world, or we call them code gardeners. And some of the best research on that's being done at Google.
Wait, is that like literally people who just like go through and make sure everything stays tidy?
Yeah, absolutely.
I kind of want that job, I think. I can just imagine myself like a Zen gardener going through the code base. Anyhow.
I mean, I think that team is hiring, so.
I'm not actually looking for a real job.
I know, but there probably are listeners who are, and if that's a thing that you're passionate about, Google is the best place in the world to do it. I'll be honest.
Fascinating.
Shameless plug, but yeah.
How has the transition been from the national labs to Google, aside from the brainwashing on Bazel?
I mean, I'm drinking the Kool-Aid pretty heavily.
Yeah.
I'm in a fantastic part of Google. I know that every company that is as large as Google has people that you'll disagree with. I know that every company has good parts and every company has bad parts. I'm not going to comment on that, of course. I will say that the part of Google that I'm in, I work under Chandler. I work with Titus, both of whom most of your listeners will know of. I'm very happy in that part of Google. I'm very happy with the variety of things I get to work with. I'm very happy with the developers I get to work with. Those of you who know me personally know that I'm very passionate about diversity and inclusivity, and getting to actually work at a company that has enough developers that we can actually talk about things like, what does it mean to write inclusive code? What does it mean to write code that is readable by more than just cis white men? What does it mean to have change lists, pull requests, as you call them in non-Google land, that are evaluated more quickly or more readily or more readable by everyone, and not just, what is the cost, what is the tax on minorities who have to get up to speed on a code base where the code was written by cis men, reviewed by cis men, cis white men, and maintained by cis white men for 5 years, and now all of a sudden you're a Black woman getting up to speed on the code base. What is the tax, right? How do we measure that tax? Because it's non-zero, right?
Okay.
I think we can all be pretty confident from a number of things that there's a non-zero tax there, right? Because people communicate differently, and Google actually has, the data to start measuring that. We can do studies on, productivity of women programmers that are not just like N = 20 studies. We can do studies on, queer and trans people of color that are not just like, that are N = 20 studies, which is like impressive, that are not just like case studies with N = 1, right? I'm very interested in understanding programming languages from an inclusivity perspective, from how can we make the future better? How can we make the next generation of programmers? How can we make programming accessible to everyone, right? How can we get programming languages to the point where it's reasonable to have it be a skill like English that's just taught in elementary schools? It's available to everyone as part of public schooling, and you decide to go into programming just like you decide to go into journalism, because the language, it's part of your background knowledge, and the opportunity is available to everyone. And that's really what I felt like Google offered me the opportunity to do, both explicitly and implicitly, just because of the size of the company, the number of engineers I get to work with, the number of engineers that are impacted by the library design I do there. And that's really played out in my first 6 months. I've done some really cool things. I've gotten to be involved in some really cool things, some of which I can talk about, some of which I can't. Everything, all of which I will hopefully eventually be able to talk about. One of the things I told Google is that I wanted to work mostly on open source. I wanted to be able to open source the things that I worked on. I wanted to be able to publish about the things I worked on. And they said, great. That's what we want you to do. So
That's awesome.
like, yeah, I'm not an evangelist for all of Google, but I definitely think my part of Google is some good people doing really good things. So I'm enjoying it. Thank you for asking.
Yeah, that's very cool. And as a cis white man, I'll say, we're starting to run low on time, but I am curious what, if you have like an example of what you mean when you're talking about like writing the code to actually be inclusive. I know I've heard discussions on like, avoiding using terms like whitelist and blacklist, instead use like block or something like that, or avoid using like master-slave relationships, use something else that is not offensive language. Like, is that kind of what you're talking about, or is there something else to it?
So there's a couple of things there, right? There is inclusive language is like the most obvious and simple thing we can do, right? It's the most explicit thing we can do. But the problem with this discussion is that when you try and come up with very specific examples of this kind of thing, right? They all sound cheesy. Like, you can come up with like hilarious examples of like why code is better because, an iOS app written by, 10 white men forgot that like, half of the world has periods every month, things like that, like random, like, ridiculous, over the top things. And they all sound cheesy. And you're like, well, that sounds like a great reason to hire women. And that is, but that's not like the point here, right? The point here is that it's a ton of little micro taxes that have to do with the way that people communicate. And we saw this more so 50 years ago, less so now. We saw this more so 50 years ago with writing, like with books, right? The turn of the 20th century, people were talking about, and that's more than 50 years ago, but women authors were talking about how books were not written in an accessible way to women, right? They were written for cis white men by cis white men. And there were a lot of women authors trying to change that, right? And there's these little micro taxes about communication styles, about ways of expressing things that are different between minorities, between women and men. And if you don't have a team that involves inclusive and diverse representation, then you don't get communication styles that represent everyone, right? And so it's really hard to describe in specific examples. That's the hard part about talking about this, right? Is that it really involves these micro taxes that start to add up. And so I try to avoid giving specific examples because that's not really what it's about in some sense, right? I think that having the data to actually measure that is a really interesting experiment, but I don't think that's. I think we should have inclusive teams and inclusive designs because that's the right thing to do, not because it makes us more money. But beyond that, it's like really interesting to be able to show companies that it also makes you more money and it makes you more productive, right? And so I think that's an interesting experience to discuss. But yeah, no, I don't have a lot of specific examples. Obviously, using inclusive language is the first place to start, right? Okay. But code is just a means of communication, and regular English language or whatever language, spoken language is a means of communicating, and has the same effects that have been measured for decades, right? So it would be surprising to me if code doesn't have the same micro taxes that involve the ways that people express things to each other. I think there's also some effects of code reviews. The way that people emotionally deal with each other makes it hard for minorities and women to get up to speed on a team. I think that anyone who's been marginalized their whole life will have certain reactions to code reviews that will cost them a lot more in terms of emotional well-being, that will lead to burnout a lot faster. And so I think doing all we can to minimize those things and really make programming accessible to the next generation, I think is something that we need to think really hard about as people who have sort of made it in programming. I think we have something of a duty to do that.
Yeah.
Sorry, I soapboxed on
it's okay.
your C++
Not at
podcast
all.
about that, and I knew I was going to do it because I love talking about this stuff, but I really appreciate you giving me the platform to talk about it.
Well, I think we are running out of time, but since we're on the subject, I did want to allow you to put in a plug for Include CPP. I think you wanted to do that.
Yeah, Include C++ or Include CPP. There's a Discord server for that. It's really about inclusivity for minorities and allies in C++. Look that up. I don't know the exact web address, but we can Google it or put it in the show notes.
Yeah. We're
also trying to get up to speed and effort for women in C++, trying to get up to the point where we have 25% women attendees by 2025. We're having a women's brunch next year at CppCon. So if you're interested in that, reach out to me on social media or in various channels. And hopefully we can start, reversing the trend that we have in C++. That's really a problem.
Right. Okay. Well, thank you so much for coming on the show today, Daisy.
Thank you so much for having me. I really enjoyed it.
Yeah, thanks a lot for coming on. That was great.